In this video, we're going to talk about finding the tangent and normal lines to a curve. So if f of x is differentiable at a point x equals c, then the equation of the tangent line to f of x at x equals c has slope f prime of c. So for example, if we want to find the equation of the tangent line to f of x equals the natural log of x squared minus 1 at x equals negative 2, that means that we want to find f prime of negative 2 first of all. And so that means that the slope of tangent line is f prime of negative 2. So that's the slope of the tangent line. So let's find first the derivative, and then we'll find the derivative plugging in negative 2 for x. So the derivative in general is, here we'll need the chain rule. Derivative of natural log of something is 1 over that something, 1 over x squared minus 1, times the derivative of the inside, times 2x. So that's 2x over x squared minus 1. If we plug in x equals negative 2, then f prime of negative 2 is equal to 2 times negative 2, so negative 4 divided by x squared minus 1. Negative 2 squared is positive 4 minus 1. So it's negative 2 squared is positive 4 minus 1. So this reduces to negative 4 over 3, negative 4/3. And here is the graph of f of x equals natural log of x squared minus 1. If we take a look at x equals negative 2 and think about the slope of the tangent line to the curve at that point, then we see that that slope, of negative 4/3, about negative 1 1/3, seems about correct. It seems like a slope that's negative, certainly, and a little bit steeper than negative 1. So negative 4/3 is the slope of the tangent line. We still want to find the equation of the tangent line. So to find that equation, we want to find an equation of the form y equals mx plus b, the equation of a line. And we know that this is going to be y equals negative 4/3 x plus b. So we still need to find b. We still need to find the y-intercept. We see that that y-intercept is going to be somewhere, around here. It's going to, so that's an approximation with that line drawn over there, but it's going to be, negative 1 point something-ish. So we're still trying to find b, the y-intercept. And to do that, we can say, okay, well, I know 1 point on this line. I know that 1 point on this line intersects with the original function, natural log of x squared minus 1. And so, okay, I know that the input at negative 2, I can find that. So what is natural log of negative 2 squared minus 1? Well, that's the natural log of 3, and that is something I do not know off the top of my head, and I wouldn't expect you to either. But if you use a calculator to find that, the natural log of 3 is 1.1 approximately. It's actually like 1.0986, but we'll round that to 1.1. And so that's negative 2 comma 1.1 is a point that is both on the original function, natural log of x squared minus 1, and on this tangent line. And so if we know the slope and we know 1 point, we can find b, we can find the entire equation of the line. And so our output is 1.1. That's why 1.1 is equal to negative 4/3 times x. X is the input. That was negative 2. That was the input. That's x. That's y. And then plus b. And now we can solve for b. So we've got 1.1 is equal to negative 4/3. I'll call that negative 1.33 times a negative 2 plus b. So that becomes a 1.1 is equal to positive 2.66. To solve for b, I can subtract the positive 2.66 over to the other side. So minus 2.66 is equal to b, the y-intercept. And now 1.1 minus 2.66, that gives me a negative 1.56. Subtracting is equal to b. And so I see that b, my y-intercept, is equal to negative 1.56, which, matches with kind of our approximation based on the drawing of our tangent line. And so now we have the entire equation of the tangent line. The tangent line has the equation y equals negative 4/3 x plus b. B is negative 1.56 approximately. So that's the equation of our tangent line. The normal line of a curve at a point is the line that is perpendicular to the tangent line. So if this is our tangent line at C, tangent line at the point C, then the normal line is perpendicular to that line. There's a 90-degree angle, so that is our normal line. And it's always the case that if two lines are perpendicular, then their slopes are the opposite reciprocal of one another. So if the tangent has slope m, then that means that the normal line has slope negative 1 over m. And so that means that if f of x is differentiable at c, then the equation of the normal line to the function f of x at x equals c has slope negative 1 over f prime of c. Negative 1 over the derivative at c, because the slope is the opposite reciprocal of the slope of the tangent line. So up above, we already took the derivative of f of x equals natural log of x squared minus 1, and we also found the derivative at the point x equals negative 2. We found that f prime of negative 2 was negative 4/3, and so that tells us that the slope of the normal line is the opposite reciprocal of negative 4/3, so that makes it a positive 3/4. And that means that the equation of the normal line is then y equals mx plus b, the slope, 3/4 x plus the y-intercept, b. And this is a new b that we need to solve for. It's not equal, or generally not equal to the previous value for b when we found it for the tangent line. So to find b, we know that there's this one point, negative 2 comma f of negative 2, that is part of the tangent line and part of the normal line. So here's our tangent line, and then here is our normal line. And we know that this point is on this point, negative 2 comma f of negative 2, natural log of 2 squared minus 1, which we already calculated above to be approximately 1.1, is on the intersection of all three of those lines. So we can use that point to calculate b. So now what we've got is that y, the output, which is 1.1, is equal to 3/4 times x. X is negative 2, the input, plus b. And so that means that 1.1 is equal to 3/4 times negative 2. That's negative 3/2, or negative 1.5 equals b, or plus b, sorry. And now to solve for b, we can add 1.5 to the other side. So we have 2.6 is equal to b when we add that to the other side. And if we take a look at, our approximation, that looks pretty good. That it would be that the y-intercept is somewhere around something larger than 2. And so our full equation of the normal line is y equals 3/4 x plus 2/6. That is our equation of the normal line to this curve. That's the equation of that red line right there. So here's an example for you to try. Find the equations of the tangent line and normal line to the function g of x equals square root of x cubed plus 1 at the point x equals 2. So give that a try and we'll talk about it in a moment. All right. So first we need to take our derivative to be able to find the slope of the tangent line, and then take the opposite reciprocal to find the slope of the normal line. So before taking the derivative, I'm going to rewrite g of x as x cubed plus 1 to the 1/2 power, so that it's a little easier to think about. Now this is a chain rule. The outside function is to the 1/2 power. The inside function is x cubed plus 1. So using the chain rule, g prime of x is equal to 1/2 times x cubed plus 1 to the negative 1/2 power, subtract 1 from the exponent, multiply by the derivative of the inside, that's 3x squared is the derivative of the inside. And so now we can maybe simplify that a bit. That's equal to 3x squared in the numerator, and in the denominator we've got a 2, and then x cubed plus 1 to the negative 1/2, that's the square root of x cubed plus 1. So then g prime of 2 is equal to 3 times 2 squared, 3 times 2 squared, we'll just write it out, divided by 2 times the square root of 2 cubed plus 1. So 3 times 4, that's 12, over 2 times the square root of 2 cubed is 8 plus 1 is 9. And so that's 6 over square root of 9 is 3, and that just simplifies to 2. So g prime of 2 happens to be 2, just a coincidence in this case. And that is the slope of the tangent line. So slope of tangent line is m equals 2 is the slope. So we still need to find the equation of the tangent line. We know that that's going to be a line, and therefore it's of the form y equals mx plus b, y equals 2x plus b, and we need to solve for b. So to solve for b, we are going to plug in the one point that's in common with both the tangent line and the original function, and that's we are looking at when x is equal to 2. So the x value is 2, and we're going to plug in g of 2, the original function, not the derivative, to see what that is. So g of 2 is the square root of 2 cubed plus 1. So g of 2 is the square root of 2 cubed is 8, plus 1 is 9, square root of 9, and that's nicely just a nice number, it's just 3. So this is the y value. The output, y, g of 2 is 3. And so plugging in those values, y equals 3 is equal to 2 times the x value is also 2 plus b. Now we're solving for b, so we're subtracting 4 from both sides. Negative 1 is equal to b. And finally we have the equation of the tangent, equation of tangent line. And that equation of the tangent line is y equals 2x minus 1. Now we'll find the equation of the normal line. So we know the slope of the normal line is the opposite reciprocal of what it was for the tangent line. So it is negative 1/2 because the slope of the tangent line was 2. So negative 1/2 is the opposite reciprocal. That means that our equation is going to have the form y equals negative 1/2 x plus b. B is the y-intercept. It's a new b that we have to find. And so we can find it by using this that we had before. This is plugging in and saying g of 2, the original function g of 2 was equal to 3. So the point 2, 3 is on the tangent line, the normal line, and the original function, but it's on the normal line. That's what we're looking at now. And so we're plugging in y is 3 equals negative 1/2 times x is 2 plus b. Now solving for b, 3 equals negative 1/2 times 2 is negative 1 plus b. Adding negative 1 over to the other side, 4 is equal to b. And so that means that the equation of the normal line is y equals negative 1/2 x plus 4. So that's the equation of our tangent line and the equation of the normal line.